아. 아. 또 아. 예, 일로 와봐. 김윤아. 김윤아. 윤아.
제일이 가져가서 다 나눠줬고 누나 착하게 다 나눠주고 너 하나 받아 먹고 초록크림 모자 할게.
예, 일로 와봐.
너 유나 주지 말고 잘 써야 돼.
딱 줄비가 너. 왜? 엄마 어디가? 불 켜야지. 불 켜야지. 불. 불 켜야지. 불. 너 듣기. 네. 응? 민아 아빠랑 시장 갈까? 응? 어디 갈까? 어디 갈까? 시장? 갈까? 원플러스 갈까? 그래, 가자. 옷 입어. 옷 입어야지 빨리. 안 갈 거야? 일로와 민아. 춤춰봐.
Boston 10 years ago from Chicago with an interest in cancer and in chemistry. You might know that chemistry is the science of making molecules, or to my taste, new drugs for cancer. And you might also know that for science and medicine, Boston is a bit of a candy store. You can't roll a stop sign in Cambridge without hitting a graduate student. The bar is called Miracle of Science. The billboards say lab space available. And it's fair to say that in these 10 years we've witnessed absolutely the start of a scientific revolution, that of genome medicine. We know more about the patients that enter our clinic now than ever before. And we're able finally to answer the question that's been so pressing for so many years: why do I have cancer? This information is also pretty staggering. You might know that so far, in just the dawn of this revolution, we know that there are perhaps 40,000 unique mutations affecting more than 10,000 genes, and that there are 500 of these genes that are bona fide drivers, causes of cancer. Yet, comparatively, we have about a dozen targeted medications. And this inadequacy of cancer medicine really hit home when my father was diagnosed with pancreatic cancer. We didn't fly him to Boston, we didn't sequence his genome. It's been known for decades what causes this malignancy. It's 3 proteins: RAS, MYC, P53. This is old information. We've known since about the 80s. Yet there's no medicine I can prescribe to a patient with this or any of the numerous solid tumors caused by these 3 horsemen of the apocalypse that is cancer. There's no RAS, no MYC, no P53 drug. And you might fairly ask, why is that? And the very unsatisfying yet scientific answer is, it's too hard. That for whatever reason, these 3 proteins have entered a space in the language of our field that's called the undruggable genome, which is like calling a computer unsurfable or the moon unwalkable. It's a horrible term of trade, but what it means is that we fail to identify a greasy pocket in these proteins into which we, like molecular locksmiths, can fashion an active, small, organic molecule or drug substance. Now, as I was training in clinical medicine and hematology and oncology and stem cell transplantation, what we had instead, cascading through the regulatory network at the FDA, were these substances: arsenic, thalidomide, and this chemical derivative of nitrogen mustard gas. And this is the 21st century. And so I guess you'd say, dissatisfied with the performance and quality of these medicines, I went back to school in chemistry with the idea that perhaps by learning the trade of discovery chemistry and approaching it in the context of this brave new world of the open source, the crowdsource, the collaborative network that we have access to within academia,